In this recording, we're going to learn about summation notation, or also called sigma notation. So this Greek letter sigma, looks like it's kind of a sideways M, represents the summation of a sequence. So it looks pretty complicated. When you first look at this, you're like, no way, that's crazy, I'll never understand that, that's impossible. I bet within a couple minutes you're going to have a pretty good handle on how to evaluate a sum represented by this sigma notation. Keep in mind, mathematicians, we like to just be efficient in our notation, right? So we don't like to write a whole lot of stuff out if we can represent it with a particular notation. And this is just a way to summarize, as it says here, to summarize a bunch of terms being added up, or in other words, a summation. Let's check this out. We're going to start with an index variable. So there's a particular variable on the bottom. In this case, it's a k or a j or an I, and it has a starting value and an ending value. And what you're going to do is just substitute one by one from the starting value all the way up to the ending value into this formula until you get to the end of it, and then you just add up all the terms. Let's look at an example. So in this first example, 1a, it says I starts out at 3. Okay, so what do I do with it? Well, I substitute it in for I into the formula. So I go 2 times 3. It's that easy. And then I keep incrementing by 1. So the value of the variable increases by unit increments, as it says. So we're going to go 2 plus 3. And then 2 times I, but now I takes on the value of 4. It increments by 1. Then the next substitution takes on the value of 5. And then I stop, right, because I've reached the final value. And then I just add up these terms. So it's a 6, an 8, and a 10. Looks like a 24 is the total sum. So you're always going to end up with a single expression that represents the sum of the sigma, or the summation. So, why don't I give you a little work time? Why don't you try to work out B through F, and play the recording when you're ready. Okay, so if you haven't paused and worked these out, please do. As difficult as these look, they're definitely doable. Okay, so first we're going to sub in a -1 in for k. Because the base is negative, let's include parentheses around. Now k takes on a new value. We're incrementing by 1, so it's now 0 squared, and so on. How do I know where to stop? Well, the final value of k is written up on the top. So I've reached it, so I stop. Now just evaluate these terms. Okay, so you're on your own now. See if you can work out the rest of them. Play the recording when you're ready. Okay, so in this example, I had to make substitutions. 0, then I subbed in a 1, then I subbed in a 2. Then I evaluated what was in parentheses. So hopefully that was obvious too. I did 2 times 0, 0 plus 1 is 1. 2 times 1, 2 plus 1 is 3, etc. Then I have the terms 1 plus 3 plus 5, which I add up, I got 9. So in this example, I subbed in 1 2 places, here and here. In my second substitution, I subbed in 2 in both places I saw I, right? And in the third substitution, I substituted I as 3, 2 different places. Then I just did the math according to the order of operations, do what's in parentheses, then multiply, so I got a 2. Do what's in parentheses, multiply, do what's in parentheses, and multiply. And then I added up 2 plus 6 plus 12. Okay, I'm going to skip number 3 for now, and I'm going to have you dive in and look at number 4. This is where we're going to write our own summation notation. Okay, so we're going to express it using sigma notation. Our answer is going to have one of these. Okay? You can use I as your index variable. And first is just look for the pattern, and then try to figure it out, and then check your work to make sure it works. So, should we work through the first one together here? Okay, let's try to find the pattern here. So, look it over and see what you see. Hopefully you recognize this is 3 squared, 4 squared, 5 squared, all the way up to 10 squared. All right, so we've got to work with these numbers. There's a squaring pattern. So I'm going to go ahead and put sigma in here. Okay, the directions said to use I as the index variable. So I'm going to start out with 3 because I see that 3 is the first number that's squared. I'm going to say the pattern is basically I squared, and it continues up until we get to the value of the index variable of 10. So I'll put that right up on the top. So our next example, we've got a little pattern going on here. Why don't you look it over, see what you see. You notice that it adds 3 each time. So, you know that D is 3. And we can write this as an explicit formula. A sub n equals, well, we start at -6, and we add 3 n minus 1 amount of times, right? I have to clean this up a little bit, so I'll do 3 times n, that's 3n. And when I do 3 times -1, that's -3. Added to the -6, -9. Okay? So that's our explicit formula. We need an explicit formula, not a recursive formula in here. So we will start with I being 1. And this is our formula, 3 times I minus 9. Let's just verify that it works for the first term. So when I sub in 1 for I get 3 minus 9, -6. Okay, it works for the first term. I do need to check which term number this is going to be. So, like, how many times do I need to keep adding to get, or in this case, yeah, adding by 3 to get to 15. So it's 3n minus 9, and when I add 9 to both sides, I get 24 equals 3n. Looks like n equals 8. So I believe the final term of the sequence is going to be the term that has an I value of 8. Finally, this example, what's the pattern? I see 1/25, that's a little confusing, and I see 1, 5, 6/25. Okay, I think I see that they are powers of I here. So that's like 5 to the -2 power, 5 to the -1, 5 to the 0th, 5 to the 1st, and then we got to figure out which power of I is 625. So you could mess around with that a little bit. Hopefully you found out it's the 4th. So now when I write my sigma, I'm going to have I equals, and I can start I at anywhere. So I can even start at -2. And what's the pattern? Well, it goes 5 to the I power. And we want to end when I is 4. Thanks for watching.